right, so now we're going to talk about something that can very precisely measure the diameter of a hole. So certainly you could use any of your calipers to do this. We saw that with our ID attributes of our calipers. Let's look at that with this hole here. So if you took your dial calipers, you could take and you'd come down in this hole and you could do your measurement. But what's the tricky problem with this? Well, how do you know you're exactly at the largest diameter of that hole? Well, you do this by kind of keeping some pressure on the dial and kind of moving back and forth to hopefully get to the very center of that hole. So if we look at this here, we're at 2 inches. We see the 8. We're exactly on the line. And I've already discovered a problem, because when I'm holding this, and I don't know if you can see that, when I'm holding it perpendicular, I'm actually exactly on the 0. When I pull it off, it's very hard to do that because you can't really hold the thumb, because you're gonna, as you pull it off, the pressure is gonna release and that dial's gonna move. So we can see here that we're actually 0.02 of an inch smaller. So we're getting a measurement of 2.798. This ring is precisely ground to be 2.800000. So you can see we're getting a level of error trying to use a manual gauge to get that ID, because you've got that issue of just trying to find exactly that diameter, staying perfectly perpendicular, and trying to do all those things, and you get a lot of error. So what if you needed to know precisely the size of a hole? Well, okay, we have yet another version of a type of micrometer, and this thing is called an Intremik. And what this does is it has these 3 little jaws on it. So as we turn this, and I have this upside down so you can see this, as I turn it, you can see these starting to protrude, right? So that's going to open up out to the hole. As I turn it the other way, they go back in. And what having 3 legs on here does is it self-centers, which is really a great feature. All right, so let's say we wanted to measure this ring precisely. We could take and put this gauge down in the hole. It's got a little clutch like our micrometer, so it takes that feel out of play. You'd actually read this with this still sticking in this hole. Now, this ring that I'm in is precisely designed to use to check to make sure that this Intremik is set correctly. So we'd expect to see it exactly on 0, which we're pretty close. I don't know if you can see that if I hold this closer here. But that's what this ring is. So this has got a size of 2.8 with a bunch of zeros on it. This Intremik, so these Intremiks, because you've got this tri-jaw design, just like our micrometers, if you have a different size hole, you need to use a different size Intremik. This particular Intremik measures from 2.8 to 3.2, if you look at those numbers on here. Okay, and so how this works is, again, as you turn the barrel, these feet are coming out further, so that diameter is getting bigger, so we're moving up here. Okay, so let's just be at our 2.8, and let's turn our barrel so we're getting slightly bigger. And this is a little bit different than our other our other micrometers, in that we don't have this 0.025 sort of scenario going on. If we turn this barrel all the way around, we do have the 0.025 for each turn. That again is going to cover up a line. So if we look here, we're at 2.8. There's our first line, second line, third line. They alternate back and forth. That first tenth, so we're at 2.8 and there's 3. There's actually this middle line here. So again, confusing. So we've got, for each line that you cover up, you need to add 0.025. The thing that's weird with this is that if you look at this increment here, between the 5 and the 10, we've got these lines here. So that's 5, 6, 7, 8, 9, 10. Between each of those lines, there's only 4 lines, which makes 5 divisions. Okay, So if you've only got 5 divisions, can you be in increments of 1? The answer to that is no. So if you took 0.001 and divided it by 5, what would you come up with? You come up with 0.0002, okay? So we actually have 200 thousandths as our discrimination for this gauge, okay? Which is different from any of the other gauges that we've looked at today. Again, they all seem to have their own little idiosyncrasies. So again, how would we measure with this? All right, let's come back to our 0 point. So we should be able to check this on our ring. So if you're going to use this, you would check it on your ring. Whoops. It shows you how delicate the pressure is on there. Put your clutch on. You'd look at this, you'd want to see this zeroed out. Okay. Now, if we were going to measure another hole, and I don't have another sample hole, but let's just assume we're putting this in a hole here. How are we going to read this? So kind of like what we saw with our depth gauge, we've got to see what we've covered up. In this case, again, so let's start back at our 0. As this diameter is getting bigger, you can see we're proceeding towards that line there. We're getting towards the 15. When we get 1 full revolution around, okay, you know you need to have 2.8, which is our starting point, plus 0.025. So we're at 2.825, and then adding on here. So again, you can see we're covering up as we go, which again, these are difficult to read. All right, so let's just go here. And I'm going to go one little tiny line past that. I don't know if you're going to be able to see that. So we were at 2.8, one line covered up, so 2.825 plus 0.005, so we're at 2.830, so that was 25 plus 5. And then we see that we've got one little extra line here, and we already decided that each of those little lines, because there's only 5 sections between the 5 and the 6, is worth 0.0002. So our dimension now is 2.8302. Again, fairly confusing gauge, but I want to introduce this to you because this is the most precise way to measure a hole because it has that self-centering capability. Trying to measure a hole with a 2-pronged measuring device leads to a lot of inaccuracy. So Intremiks are actually a really nice, precise gauge for measuring inner diameters.